In this last video, which is the last part of lesson 1, we need to take a look at the back side of that second page, and it says up on the top, combinations. Now, combinations are related to the other two groups. In some cases, you'll find them very similar. But again, our focus here is being able to find arrangements of a subgroup within a group. How many exist? Now, where this one differs from what we were doing in the previous on permutations is the order in the group does not create another unique subgroup. So if you're selecting a group of 4, it doesn't matter what order those 4 are in, it's still the same group. But in a permutation, when you choose 4 from a group, those 4 are going to fill certain specific positions. So when you move them around, then it does create a unique subgroup. So what we need to do is, because we're going to have repeats that are not unique, we need to be able to divide them off in our formula. So you see the definition, we have NCR again, it equals n factorial over r factorial times n minus r factorial. And again, n is the size of the big group, r is the size of my subgroup, and then n minus r is for the purpose of calculating those numbers of positions. That extra r factorial divides off any duplicates that might occur. Okay, now again, you've got factorial buttons on your calculator. You've got permutation button. You've also got an NCR, a combination button. So typically what you do with those buttons, though, you type in the N, you hit the NCR button, and then you type in the R, and then you hit enter. And that should give you a number that correlates with what you would get based upon what the formula would find for you. Okay, now let's look at an example, and I want to note this example 2 different ways. One, how it would be a combination, and one how it would be a permutation. So I've got a varsity basketball team, and this varsity basketball team is made up of 12 people. And in this example, everyone can play any position. Okay, so I'm not designating a point guard, a shooting guard, a 1, 2, 3, 4, 5. I'm not designating any of those positions. I'm just saying, okay, 5 people, get out there and play. Okay, when the 5 are generally chosen like that with no specific order in mind, okay, that's a combination. And so in this example, to select that starting 5, to look at how many possibilities there are, okay, then I'm going to take 12C5, which becomes, as you can see when I plugged in the definition, 12 factorial over 5 factorial times 12 minus 5. And then I've simplified the 12 minus 5 to a 7. And as you see to the right, I wrote it out so that I could cancel these 7 factorials. And then I wrote out what was left so that there were no factorials. And now you can go in and start simplifying further if you wish. So 5 goes into 10 twice, 3 goes into 9 3 times, and then 4 times 2 is 8. So I can cancel with that 8. And again, all you've got left is 12 times 11. And then this 2 and this 3 up here, I can make that a 6. That combination of numbers, if I multiply those together, you get 792 different starting 5s that you could create. Okay, now, like I said, I was going to contrast that a little bit. Okay, so let's say, for example, I got 12 members. I want to select a starting 5 where one person is going to be my designated point guard, the number 1 spot, and then a shooting guard, and then a forward, and then a center, etc. Okay, so each one is going to play a specific position. Okay, that would be a little bit different because this time, because of that positioning, okay, a mix-up would create a new starting 5. Okay, in terms of their roles on the starting 5. So that would be an example of a permutation, and then I would have to use that formula there. Now, the problems that we're going to look at on this next worksheet follow 2 kinds of examples. The first problems are just plug in calculate, or use your calculator in the NCR button. So if you look at 1 through 6 up there, okay, then it's a simple use the formula or use the calculator to find the number of arrangements. Okay, now number 3 looks a little different than some of the ones we've looked at. I'm going to use the formula to actually show you what happens here, because this is a possibility. Okay, so according to the formula, then this would be 9 factorial over 0 factorial times 9 minus 0 factorial. Okay, as combinations go, okay, that's what it would look like. Now, remember, as I said, 0 factorial is a special number. 0 factorial is always 1. So this becomes 9 factorial over 1. 9 minus 0 is 9. So this becomes 9 factorial. And then when you simplify, you get 1. There's only one way that you could take 9 items and break them up into 0 groups. Okay? Or groups of size 0. Okay, so there again, it's nice to look at some of the variations of what can occur. And that's a good example. Okay, as far as the other problems down as you go down the page, okay, number 9. Number 9 is like the varsity basketball example I just showed you. Number 9 says, how many ways can 9 starting players be chosen from a softball team of 15? And again, you know, what we're looking at here is that those 9 people can play anywhere. When you start designating first base, second base, third base, pitcher, catcher, that would be permutations. Okay, but because we're just choosing and they're going to go out there and fill the spots and play, that would be a combination. So in this example, 9 players out of 15 would be 15, C, and then 9. Okay, so plugging that in, there would be 5,005 different ways you could do that. Okay. So again, that's from the calculator part of it. Okay. So, but you could write it out, do it that way as well. Okay. You know, be able to use the formula. I don't expect you to memorize these formulas. They will be given to you, but you know, be able to use them. Okay, and I don't expect, like I said in previous video, I don't expect you to memorize the difference between them, because again, we just don't have time to look at it in the detail that I'd like to. The last worksheet kind of shows you that. You've got G2 says mixed combinations. Okay, and so it says first thing, divide or decide whether the problem is a permutation or combination. Then to find each one. I gave you that off to the side. Okay, I didn't want you to get hung up in that again, not at this point. But in each one of these examples, you're going to set up the formula, the NPR or NCR. In some cases, you can even use what we did in section 1 on the accounting technique. Okay, some of them are like that. Okay, so like number 3, for example, it says Mike has 9 baseball trophies to arrange on a shelf. How many different ways can they be arranged? Well, this is, again, you can do this 2 ways. This is either going to be, and it says a permutation here, it's either going to be 9p9, or as we had an example like this earlier, that's just going to simplify down to 9 factorial. Okay, either way. Okay, when you're taking and rearranging all of the items, you can go back to what we talked about there. Number 5 is very similar to that. Okay, but again, I've given you the methods there. Set it up like I did in an example like this if you can, and then just go from there. Okay. The last one I wanted to look at was number 7. It tells you have combinations again, but this is for several items. So I wanted to look at how do we do this when it's broken up into more, it's kind of a combination, a combined type of situation where you have multiple things happening. So how many different ways are there to purchase 2 CDs, 3 DVDs, and 1 set of headphones? Again, using combinations. Well, what I'm going to do is I'm going to break this up into 3 smaller problems. So I have 7 CDs, and I want to choose 2. I have 5 DVDs, and I want to choose 3. I have 3 headsets, and I want to choose 1. Okay, so I need to find 3 different numbers, and then just like we did with the cheeseburger problem back in section 1, I'm going to take those 3 numbers, okay, and I'm going to multiply them together. Okay, so when I take 7, combination 2, it tells me that there are 21 different ways I can do that. Okay, when I go 5, combination 3, I get 10, and then when I go 3, combination 1, I get 3. So the total number of different ways I can do that then are 630 different ways. Okay, so that's a much more complex problem than the other ones, but again, a good problem, and shows how you can take this to a slightly higher level. Okay, so good luck with completing those other ones. If you have any concerns or any problems as you start working them, again, send me a note, send me an email. You'll have, the rest of this week to finish this thing, and then we'll move on next week. Okay, so thanks.